Hey, technology, stop. Where are you going? In this podcast series, as you know, I'm talking about technologies, past, now, and future developments. And today's topic is a new threshold in neuroscience, uploading the brain of a fruit fly to computer. You didn't hear wrongly. Scientists from Eon Systems have uploaded the brain of a fruit fly. Then they have connected it to a virtual body, and now they are simulating it in a physics engine. I will share a link to Commons which shows that brain emulation at the same time the behavior of fly in a video. So, if the claims are true, this is the first full brain emulation in the world that presented before week. Actually, it have cloned this brain have cloned to computer 2 years before 2 years ago, but now the brain have been revived. So that brain clone has 125 neurons and 50 million synaptic connection. When they have fired that emulation, the unreal fly started to behave like a real fly. It cleaned itself, walked, drank, or etc. And there isn't anyone who teach to that fly to how can it do these things. There is a circle. The sensor input goes into brain, the unreal brain, fires neural activity, then generates motor control orders and moves the unreal body or etc. So actually, their only goal isn't emulating a fly's brain. After that brain, a mouse's, then lastly a human's brain. Think that if a fly's clone brain can behave as a fly without giving orders to it, like saying be clean or walk or etc. What would a human brain does? Like before answering these questions, let's go inside of its history and logic. So think that a man who lives in a city and you don't have any map, how can you know where he is going? In brain, the situation isn't different. You have to know which neuron connected to another neuron, which way signal goes, which connection is stimulant, which stops the signal. So when you have this information, you will have the map of the brain or the connectome of the brain. The first full connectome made by Sidney Brenner. The connectome of a worm named C. elegans. It has uh, 302 neuron and 7,000 synaptic connection. Also, they have a Nobel Prize because of that innovation. Then, in 2023, a larva fruit flies brains connect Tom had made, and it had 3,000 neurons. Lastly, the project Flyware, which I'm talking about. Malamurti, the history of that project is Malamurti and Sebastian Song hardened a fruit fly's brain in chemical ways and sliced it into 7,000 layers. Then uh, they took uh, 21 million photos in electron microscope of every layer. After that, these photos have shared with public, but they had a question in their minds that is it possible to make a map or a connectome of that brain? The answer was yes, but it wasn't easy. First, they had given these data to AI, but it did lots of errors. So they made a consortium named Flywire Consortium, which will fix these errors on that wrong map, and all the laboratories from oh no and laboratories from all over the world have supported them. In that project, they found 5,000 new type of neurons, but having a map doesn't say everything about the people which lives there and where these people are going, or etc., or the uh, direction of way. Actually, science had experienced that very badly. In 2011, a group of scientists wanted to simulate a C. elegans worm with whole body and which its brain connectome had already done. But as I said, not only brain, with everything, with muscles, with sensations, and the name of that project was Open One. Despite the fact that they have made their own models for emulating neurons, own physics, angel, or etc., they couldn't. Also, the project haven't been finished now. So, because a connectome doesn't say a neuron's features like ways of a synaptic connection, ion channels, features of ion channels, or etc. Yeah, actually, to sum up, it doesn't say electrical characteristics of every neuron, which is special for everyone. If you look from that perspective, it's a big threshold in history because it emulates even a real brain. At the same time, it connects this emulation to a virtual body. The most important leader in that innovation is Philip Shue. He was following the finishing of Flywire, and when it finished, he was curious about if it could predict behavior of a real brain. So first, with machine learning, he find the features of that map, that paths in the map. So then he used a very basic neural model, and uh, it was it was so basic that it could work on a normal laptop, a usual laptop. This model was be able to, in the final, uh, this model was be able to predict the behavior of a real brain with accuracy up to 95%. Okay, signals are processed, neurons fired, but there's there's nobody that it could use, it could move. The input is manual and the output is read with an Excel table. Ion had added Phillips' model to a physics engine and a biomechanic model named NeuroMatchFly. This biomechanic model had everything about a fruit fly's body up to seeing and hearing. One of that biomechanic model inventors is Turkish doctor Pembe Gizem Özdil. She modeled the clinic movement and matched with that Vera activity, also the other software. She is the one of the three main inventor of that project. So, Ian made a circle which includes perception, process, action, and feedback, and it goes to infinite and works by itself. Okay, that's good, but What will happen when we clone and simulate a bigger one? In a bigger brain, every neuron wouldn't be almost same, unlike a fruit flies. What I say? To be continued.